For a very long time, scientists believed that the space between galaxies was almost completely empty. When astronomers looked through telescopes, they saw bright galaxies surrounded by enormous regions of darkness. But what if that darkness was never empty at all? What if it was hiding more matter than the galaxies themselves? Those vast regions appeared silent and lifeless, stretching millions of light years from one galaxy to the next. So, scientists began asking a simple but unsettling question. If the universe is full of matter and energy, what is really floating in the space between galaxies? As telescope technology improved and scientists began studying the universe in wavelengths beyond visible light, that darkness slowly began to reveal its secrets. The space between galaxies, known as intergalactic space, turned out to be anything but empty. Instead, it is filled with matter that is faint, spread out, and difficult to detect. What scientists have now confirmed is that this space contains massive structures that play a critical role in shaping the universe itself. The first major discovery came from studying hydrogen gas. Hydrogen is the most abundant element in the universe and the primary building block of stars and galaxies. Astronomers expected most hydrogen to be locked inside galaxies, but observations showed something surprising. Enormous amounts of hydrogen gas were floating freely between galaxies, forming long, invisible strands that stretch across vast distances. These strands connect galaxies like threads in a cosmic network. This network is now known as the cosmic web. It is a massive structure made of gas and dark matter that spans the entire universe. Galaxies are not randomly scattered through space. Instead, they form along these filaments where matter is slightly denser. The regions between filaments are emptier, but even there, matter still exists. This discovery reshaped how scientists understand large-scale cosmic structure. The universe is not a collection of isolated galaxies, but a connected system held together by invisible frameworks. As astronomers studied galaxy clusters, they noticed something even more unexpected. They began detecting stars that did not belong to any galaxy. These stars were drifting freely through intergalactic space, untethered to any galactic center. Most of these stars were once part of galaxies but were violently ejected during galactic collisions. When galaxies pass close to each other or merge, their gravitational forces become chaotic. Stars can be ripped from their orbits and thrown outward at enormous speeds. Over time, these stars escape their home galaxies completely and begin drifting through intergalactic space. In some galaxy clusters, scientists estimate that up to 1/5 of all stars exist outside galaxies. These intergalactic stars are incredibly lonely objects. They travel through darkness for billions of years, glowing faintly with no planets or stable systems around them. Their existence is direct evidence of the violent history of galaxy formation. Even more surprising was the discovery of planets floating without stars. These objects are known as rogue planets. Unlike planets in our solar system, rogue planets do not orbit a sun. Many were likely ejected from their star systems during gravitational disturbances early in their formation. Others may have formed alone when collapsing gas clouds failed to ignite into stars. Detecting rogue planets is extremely difficult because they produce almost no light. Scientists find them using gravitational microlensing, a technique that detects how their gravity briefly bends light from distant stars. When astronomers applied this method across large regions of space, they discovered something astonishing. Rogue planets may outnumber stars in the universe. Trillions of cold, dark worlds may be drifting through intergalactic space completely unseen. Although these planets are frozen on the surface, some scientists believe that internal heat could still exist deep beneath their ice layers. Radioactive elements in their cores could generate warmth for billions of years. In theory, subsurface oceans could exist even in complete darkness. While this does not mean life exists there, it expands the range of environments scientists must consider when thinking about habitability. Another strange phenomenon discovered between galaxies is a faint glow known as intracluster light. This light does not come from any single galaxy. Instead, it is produced by stars that were stripped from galaxies during collisions and scattered throughout galaxy clusters. Individually, these stars are dim and difficult to detect. Together, they create a ghostly glow that fills the space between galaxies. Intracluster light acts like a fossil record of galactic violence. The brighter the glow, the more collisions occurred in the past. By studying this light, astronomers can reconstruct the history of galaxy clusters and understand how they evolved over billions of years. The space between galaxies is not calm or static. It is shaped by constant motion and interaction. One of the most important discoveries came when scientists searched for missing matter. According to theoretical models, normal matter made of atoms should account for a certain percentage of the universe. But when astronomers added up all the matter inside galaxies, stars, and visible gas, nearly half of it was missing. For decades, no one knew where it was hiding. This hot intergalactic gas forms through a slow but powerful process tied directly to the growth of the universe. As galaxies and dark matter pull material toward them through gravity, gas falls inward along the filaments of the cosmic web. During this fall, the gas is accelerated to enormous speeds. When it collides with other streams of gas or encounters denser regions, it is violently shocked and heated to extreme temperatures. For a long time, this gas remained hidden because it does not clump together like stars or galaxies. It spreads out evenly, making it almost invisible against the background of space. Astronomers had indirect evidence of its existence through computer simulations, which consistently predicted that large amounts of normal matter should exist outside galaxies. The challenge was proving it observationally. Only with modern X-ray telescopes were scientists finally able to detect faint absorption and emission signatures that confirmed the gas was real. This gas also plays a crucial role in galaxy formation. It acts as both a reservoir and a regulator. Over time, some of this hot gas cools and falls into galaxies, fueling new generations of stars. At the same time, energetic events inside galaxies, such as supernova explosions and active black holes, can push gas back out into intergalactic space, reheating it and preventing star formation from happening too quickly. In this way, the warm-hot intergalactic medium helps control how galaxies grow and evolve across cosmic time. Beyond visible matter lies dark matter, which dominates intergalactic space. Dark matter does not emit or absorb light, making it impossible to see directly. Scientists know it exists because of its gravitational effects. Galaxies rotate too fast, and galaxy clusters behave in ways that cannot be explained by visible matter alone. Dark matter provides the missing gravity. In intergalactic space, dark matter forms vast halos and filaments that guide the movement of galaxies. It acts as the skeleton of the universe, with visible matter collecting along its structure. Without dark matter, galaxies would never have formed, and the universe would look completely different. Everything we see floats within this invisible framework. Even in the deepest voids, something else exists. Ancient radiation left over from the birth of the universe fills all of space. This radiation, known as the cosmic microwave background, is the cooled echo of the Big Bang. It is present everywhere, even in the emptiest regions between galaxies. This means there is no true emptiness in the universe. Space itself carries memory. When scientists combine all these discoveries, a far richer and more complex picture of the universe begins to emerge. The space between galaxies is no longer seen as a simple gap or an empty stage where nothing happens. Instead, it is now understood as a vast environment filled with diffuse gas, wandering stars, free-floating planets, invisible dark matter, and ancient radiation left over from the birth of the universe. All of these elements interact slowly but continuously, shaping the large-scale structure of the cosmos over billions of years. This intergalactic environment is governed primarily by gravity, which acts as the silent architect of everything we see. Gravity pulls gas along the filaments of the cosmic web, feeding galaxies and galaxy clusters, while also stripping material away during collisions and close encounters. Over immense spans of time, matter flows in and out of galaxies like a cosmic circulation system. Galaxies grow, merge, and sometimes fade, but the space between them remains the main highway through which matter and energy travel. This changes how we understand our place in the cosmos. Our galaxy is not an isolated island floating in nothingness. It is one node in a massive interconnected web. Most of the universe's matter exists outside galaxies, quietly shaping everything from behind the scenes. Future telescopes will allow scientists to map these intergalactic structures in greater detail. They will trace gas filaments, measure dark matter flows, and study rogue worlds drifting through the void. Each discovery brings us closer to understanding how the universe truly works. As we continue to explore the universe, one thing is becoming clear. The greatest discoveries are not always found in the brightest places. Sometimes they are hidden in the darkness between galaxies, where matter drifts quietly and history unfolds over billions of years. What once looked like empty space is now revealed as a powerful engine of cosmic evolution. shaping how galaxies form, grow, and interact. Every new observation reminds us that the universe is far more connected and alive than it first appeared. If you enjoyed this deep dive into the hidden side of the cosmos and want more science stories explained in a calm and clear way, make sure to like this video. Subscribe to the channel for more explorations that reveal what the universe is really made of, and turn on notifications so you never miss the next journey into the unknown.